Welcome back to We Coding Along. It's Sam, and today we'll be starting our data structure and algorithm series, where we'll be covering the basic foundational top concepts and data structures that we'll need to know actually to start being able to solve good questions and also be more confident while solving questions and just understanding the whole concept of why we need data structures and algorithms, why they're so important, why almost every interview you go to, you must get a data structure and algorithm question, while top companies like Google, Amazon, Facebook, and all these FANG companies are asking this data structures and algorithm questions. So yes, so as you can see, I will be covering what we'll be covering in this series of topics. And number one, we'll start with what are or what is data structure and algorithm. What is it in its basic, like most simplistic form, like why is it needed? And after we go through that, what is data structure, what is algorithm, we'll go to time complexity. So I'm sure, and if you have not, it's no problem. We're going to go through, you've heard of O of n, O of n square, and all this. So we're going to go through them and just understand the basic, like why we use time complexity, why they're so important, and what they're used for, and how they can help us make more efficient code. And after that, we'll go to this concept called recursion. I feel this is a very underrated concept. A lot of programmers don't dig deep into it and build a solid understanding of recursion. And this is recursion is something you're going to see throughout, and it's something that you're going to see throughout your journey in this data structure and algorithm. And understanding it fully will help you in more complex data structure and algorithm like trees and queues, not even queues, but like trees and like more and dynamic programming too. So it's very important to have a deep understanding of recursion, and we're going to go through that in this series. And after that, we're going to go through sorting. And yeah, even sorting is something you're going to come across through a lot of times. We're going to go through what is sorting, the different types of sorting, and like why we use the sorting algorithm, when we should use the sorting, when we should use the recursive algorithm. I mean concepts and algorithm, yeah. And after that, we'll start with the data structures, and we'll start with arrays. And after arrays, we'll go to linked lists. In arrays, we're going to also go through when you should use an array, when you shouldn't use it, when it's more better to use it, and all that. And after that, we'll go through linked lists, and the same thing too. We'll go through the fact of like when you should use it, because the most important thing about this data structure and algorithm, the data structure starts, and the fact is you have to know what type of data structure you should use for certain problems. So that's what is going to be very, very important, and that's something we're going to go through in this series very well. And after that, we'll go through the stacks, and as you can see here, we'll go to the queue, and you can see we're only going to discuss linear data type because this is the foundation, this is the basic. From here you should be able to go to the other more complex data structures, and having a good foundation, you'll see the result of that for sure. So yes, that's what we'll be covering in this series. And yeah, the next part is what to expect in this series. So you're gonna spend your time on understanding data structures and algorithm. What should you expect? You should, number one, in this series, after finishing this series, you should understand the importance of data structures. Why are they so important? Why are companies always asking these questions? Are they just asking it for asking sake, or are they really things that they go through in the company? Of course, there are things they go through in the company. So I'm going to show you the importance of data structure and algorithm. The second is a practical understanding of when to use certain data structures and when to use certain algorithms. That is very important because if you know this, you are able to build efficient code, which is something that the moment you can do, having a job is not going to be a problem. Getting a job offer is not going to be a problem because these companies are looking for exactly this: people who can build efficient code, people who know when to use all this, people who have deep understanding of the foundation of all this. So, yes, that's what we're going to cover. And After this, I feel you should be more confident in problem solving, and especially even unknown problems. That means working in a company like Google, Amazon, they deal with problems that no one has really gone through, no one has seen. It's not something you're going to see in Stack Overflow. It's not really something you're going to see in Lead Codes. So how do you solve this problem? You have to have a deep understanding of data structure and algorithm to be able to solve these problems. So that's what I hope after this course you should be able to know. You should have this deep understanding that you should be able to solve problems that no one has come through. You should be able to use your past knowledge, the things we're going to cover in this subject, to be able to actually solve new world problems. And also, I hope this will also bring this interest, because some people look at this as, oh, I have to do this. If you have that mentality, you're not going to go far in this. So the best thing is to actually build that interest of problem solving, build that habit of problem solving, because that is a trait that every company is looking for. Every big company is looking for. Every company that has scalable content, every company that is dealing with millions of customers, they're looking for engineers. They're looking for software engineers that can problem solve. And also, I hope after this, even if you're going to be lacking in some parts, you will know the parts that you're lacking in, which is also a half of the problem solve, knowing the places that you're deficient at, and also being able to tackle those and going more in depth in that, even without this course, going on your own then after that. So these are the things that I expect to be understood and to know, for you to know when we finish this course, this series. So yes, let's get to it. So the first, yeah, of course, what are data structures and algorithm? So to start this, we have to first look at a computer and ask ourselves, what does a computer do? So fundamentally, at the highest, at the like fundamental, at the basics, at the basis, a computer does two things. It performs calculations, and it performs them extremely fast. 1 billion calculations per second. So that is extremely fast. And number two, it remembers results. It has a storage. It stores. So at the core of every computer is storage and computation of something we call data. And as you can see, this question is, what are data structures? So the definition of data structure is when we organize, when we manage, and when we store this data in a format that enables us to efficiently access it, which is important. That means efficiently query it, efficiently take it, efficiently know where it is and modify it. And so when we can access the data and we can modify the data, this enables us to make data-driven decisions. And what are data-driven decisions? These are decisions, from the name you can understand that. These are decisions that are data-driven. These are decisions that are made not because of one person's intuition in the company. No, this is made from all the data that has been collected in the company. So this is very important, and this is why companies are so concerned about this, because having good data structure and algorithm, having engineers that are good at this enables them to be able to make better data-driven decisions, which in other words makes them more money, which makes their company more productive, which makes their customers more happy. So that's part of it, and I hope this really explains it in its basic and fundamental core. So let's give an example. I'm sure you're like, oh, what is this? This is a pharmacy. This is an old pharmacy. And this shows the importance of data structure and algorithm. Because when you organize, as we said before, you have to organize, just like this pharmacy here. They organize everything. Everything has a label. Every shelf has a label. Every whole shelf has a label, just so they know where to go when a customer asks for a certain product. And this is the same thing. If you just keep stumping data in a certain place without organizing it, without structuring it well, you will see number one, it's going to get filled up fast, just like a suitcase too. If you just keep on stumping, putting your clothes without organizing, folding them inside your suitcase very well, you'll see the suitcase will get really filled up fast, and you see you won't be able to put as much clothes as you would be able to put if you actually took care of the clothes and actually put them in the right place and just structure the clothes well. Yeah, so that's part of it, and it might seem very basic, and it is. So yeah, this is really what it's all about. So another thing is, why do we need? This is a good question. Why do we need data structures? So we need data structure number one for efficient storage. The example I gave, if you don't arrange your clothes properly in the luggage, it takes more space. So we want to be able to put more data in certain locations. And the way we can do that is by efficiently storing them, efficiently managing them, and efficiently organizing those data, which makes us, as I said earlier, put more data in this certain location. And also, number two, fast query. That means arranging the data properly allows us to retrieve the data faster. And the example I gave earlier, the pharmacy, arranging the data in any this is something that is practical in life, in any walk of life. If you arrange something well and put it in the right place, not just throw it around, you will be able to retrieve it. You will be able to find it when you need it. So this is very important. And the example is a pharmacy, in the library, before computers, the library had different shelves with different names, and all the books had to be put in a certain shelf. Some were color coded, some were just different ways to actually be able to recognize, oh, this certain book is in this certain place. So this is another thing. Number one, for efficient storage. Number two, for fast querying. This is why we need data structure. This is why big company needs engineers who are good at data structures and algorithm. And the third one is to make data-driven decisions. And these data-driven decisions are very important because this is the lifeblood of a company. This is what makes the customers happy. This is what makes the employees happy. This is why the company is in business. So making data-driven decisions. Maybe 5, 10 years ago, decisions were made by intuition, by maybe one employee, by the head of the company. But right now, decisions are made from data-driven decisions. Decisions are made from all the analytics that are being taken from maybe, for example, you being on a site, hovering on a, even without clicking, hovering on a post or clicking on a post or going to a website. All this data is being tracked, and all these data are going to be used to make data-driven decisions. So you can run analytics and find insight to make data-driven decisions. So I hope with this we understand why we need data structures. So, as I said, why do companies ask this data structure and algorithm questions in interviews? And we can see it's for data, is to be able to have engineers who can problem solve, who can solve this problem in an efficient way. I had a friend once who was working in Microsoft, and he actually had a problem that they gave him a problem, and a certain problem, I can't really remember what problem it was, but he, it took days to solve that. And just because of his good understanding of data structure and algorithm, he could reduce a problem that was taking days to load to actually take only 1 hour, which was significantly less time. And this is the power of data structure and algorithm. And these are the kind of things you will go through when you start working in these companies. So that's why a good foundational understanding of this course, of data structure and algorithm, is something companies, especially big companies that are dealing with big data and have big customers and large customers, that's why uh, um, they need programmers who have a good understanding, who are really good at data structures and algorithm. So now we've covered data structures. Now let's go to algorithm. What is an algorithm? And you know, we can see this guy here. Let's say he's going to the airport. Yeah, you can see Frankfurt, Budapest, Paris, Istanbul. He's going to the airport. Don't know where he's going exactly, but he's going to the airport. That's one thing we know. So, going to the airport, for sure, there are different ways of going to the airport. As you can see here, this is one route. You can follow like this and you go to the airport. This is another route. You follow like this, you go to the airport. So, Number one, what we're learning from this is that there are different ways to go to airport. So that means there will be different types of algorithm. There are different algorithms. And that's it. Algorithms are the steps taken to solve a problem. And they can be multiple, as we've discussed, multiple ways of solving a problem. There can be multiple algorithms to solve a certain problem. And the thing is, some algorithms will be faster than the other algorithms, some will be more efficient, some will be worse, some will be slower. So, this is another thing about knowing what type or what algorithm to use for certain data structures. So, you see a good foundational understanding of data structures and a good foundation of understanding of algorithm will make you make good decisions to find the most efficient way, the fastest way, the way that is more efficient to actually solve problems. And this will make you a very, very valuable employee to your company. So this is the first series of the data structure and algorithm series that I'll be going through. The second one, as we discussed earlier, will be time complexity, which will be which will be coming soon. And hopefully you have a good understanding of the basic, because I always stress is the foundation is the most important. If you have a good foundation, you know where to go from there. If you don't have a good foundation, you just get confused. So I hope we have a good understanding of what data structures and algorithms are. And yes, so don't forget to subscribe. Don't forget to click the bell notification. Don't forget to like this video if you had uh if you gained something from it. And yes, I'll I'll be posting the series, and yeah, see you soon. Goodbye. And if you don't really understand it, rewatch the video, and yeah, just make sure you understand this, because the next things are going to be coming thick and fast. So yeah, goodbye. Take care.